All right, air temperature remains constant. Evaporating water in the air will blank the relative humidity and blank the dew point. Well, evaporating water in the air, it's kind of easy for the first one. All right, if we put more water in the air, it's going to be more humid, more moisture. All right, it's going to be muggy outside. You can just feel it sometimes here in Virginia Beach. Dew point, though. Let's look at this. All right. First off, we're going to increase the relative humidity, so we can get rid of A. All right, so it's going to be B, C, or D. And I'll tell you right now, it's not changed. We're going to scratch that one out because we know it's going to change. So we're going to have to see if it decreases the dew point or increases the dew point. So if we put more moisture in there, basically you have to remember this. The dew point is the temperature you have to get down to for water to condense. That's why dew forms on the grass. Basically, the blades of the grass cool down at nighttime faster than the air temperature above it does, and moisture in the air will condense on the blades of grass and form dew. It's why when you have your iced tea out in the summertime, you get the condensation on the outside of the glass because the glass itself is colder than the air outside, and that moist air, when it hits the glass, it condenses back into liquid water and then runs down the side of the glass. It's the reason in the wintertime when you blow out, you have moisture in your breath, and it's also at body temperature, 98.6 degrees. But when you blow it out, it hits that colder air, and colder air can't hang on to that moisture that the 98.6 degree air can, and so it condenses and forms a cloud. You call it seeing your breath. So this is what's happening. Cold air can't hang on to it, as well as warm air can. So basically, the dew point is the temperature you have to get down to for it to condense. Here I see if I'm at 100% relative humidity. If I have, this would mean I have 10% is how much the air can hold. I'm sorry, not 10, at 10 degrees, I'm filled up with my water vapor. It can't hold anymore. But if I heat the air up, there's more room now that I can hold more water. So here's my original water vapor, and it's only half full. That's what relative humidity is how much can it hold compared to how much is in there. And if I heat it up even more, up to 30 degrees, now there's much more room for water vapor. I can hold even more. And so the opposite is true for the dew point. The dew point's the temperature you got to get down to for it to be 100%. It can't hold anymore, and it'll squeeze out and form clouds. So let's look at like 30 degrees Celsius. The question says, if I was to evaporate more water into it, if I was to make this blue dot bigger, I wouldn't have to cool it down as much. I wouldn't have to get down to 10 degrees Celsius anymore because I would only have to cool it down a little bit to get down to where that blue dot is. Basically, evaporating more water into it actually increases the dew point. I only have to get down to like 28 degrees Celsius now for it to be full. And so it would be completely saturated with more water in it. And so it would just condense much faster.